Thank you very much. Give me 1 second to set up here. How's that looking? So, how's everyone feeling? We've got 2 days of Codebeam ahead of us. Look, it's an absolute honor to be speaking to you today. The first time I came to Berlin was actually 9 years ago, in 2016 for ElixirConf, and it was in Berlin. And it's pretty amazing and a privilege to be back here in Berlin and be able to sponsor this amazing conference and also the broader open source community and hang out with you all for a few days. And I do want to give a massive thanks to the team that puts all of this together and to all of the community folk and organizers for coming together and putting also other events on. So look out for some of the other events that are happening. But I hope you're fired up and ready for an amazing conference. So let's start with a little fictional, maybe fictional scenario. Imagine waking up sometime in the not too distant future, and before you've even opened your eyes, you utter your amazing app idea for your ambient computing device to pick up. And maybe it's Uber for donkeys or something equally as amazing. And you don't think about it anymore. You get up, bleary-eyed, have a shower, get dressed, make yourself a cup of coffee, or whatever your favorite morning beverage is, and grab some breakfast, sit down at your bench and open your laptop. And there waiting for you is 10 versions of your crazy app idea. Now, you may have some questions and some follow-up questions. What is this mildly dystopian version of the future? How do you review a whole application, let alone 10 or more versions of it? Would it even be safe to deploy? Good questions. And have we just invented the software version of the useless box? And have we reduced what we've done for my whole career, and possibly yours, software, to a hobby that we might, do on the sofa on a Sunday afternoon? I really hope not. I think that's a little dystopian, but who knows what's going to happen. Computers are getting really, really good and very quickly at writing code. And so maybe it's time to start looking for that new hobby. So let's zoom back to the past, the real past, 1865 to be exact. And this was in the UK when James Watt invented a more efficient steam engine. The British government was looking at coal demand and predicted coal demand and was figuring out how to plan for that. And they expected coal demand to drop significantly because the engines were so much more efficient now. But instead, coal demand absolutely soared over the next few years. And Jevons, the economist, had basically observed that efficiency counterintuitively increases demand for the thing. How does that apply to software? Well, when programming becomes easier, then software naturally becomes cheaper. And when software is a lot cheaper, just like the coal way back when, we're going to get a lot more of it rather than getting less. Because anyone can do it now. Now we're seeing the rise of vibe coding produced by non-programmers. This is going to get messy. And perhaps we're going to see folks that aren't really technical but really want to build their crazy app idea speedrun every single programming or software engineering mistake we've ever made. And we've seen some of them already. And there were signs. That's actually a real screenshot, by the way. I don't know how serious that is, but it's definitely a thing. Now, the surface area of software is just going to continue to increase. And so maybe we won't be writing quite so much code in the same way that we've always been doing it, but there'll be plenty of things for us to do. And it's worth pointing out that we've definitely seen a lot of AI hype. Sam Altman, a few weeks ago, even started saying the word bubble. And bubbles typically start with over-enthusiasm, inflated expectations, but end up having a massive impact over the longer term. Think of things like the dot-com boom. We still have the internet today, but we got a little bit excited around the turn of the century. And crypto. Yes, very bubbly, very overhyped, but it's still with us. So what is programming really? I would argue it's the translation of vague human desires into something that a computer can understand. And let's take a quick look at how programming has changed over the centuries. In 1801, this was arguably the first program, weavers used the Jacquard loom and programmed weave patterns into punch cards and automated how cloth was made and rugs and so forth. Charles Babbage in 1834 designed the first general-purpose computer. He called it the analytical engine. He never managed to complete it, but that is a real part of the design. And then Ada Lovelace, who was arguably the first computer program, wrote the first computer program to calculate Bernoulli numbers, which is seriously impressive given that she didn't actually have a working computer to do the program on. And so she was also the first to think about encoding information other than numbers. So she was thinking about, well, how do we encode music and language? Babbage, he was all about the number crunching. Speaking of number crunching, this was a tabulating machine that was used to massively increase the speed at which US census data was processed. And this was a data-driven program and data-driven computer. And I think it took about 7 years to process all of the census data, and this made it really took way less time. I think it was in the order of about a year. And then we got the first digital computers. And this was programmed by plugging in cables to build the program, plugging in components. And there was entire rooms, I don't have the picture here, but that's just part of the ENIAC system. There was entire rooms with cables stretched all over the place. So that was some of the earliest forms of programming, and a very quick view of those. But from 1945 on, we got what seems more familiar today, writing text into an editor of sorts. First, we got assembly, very low-level machine language, and then we got the more math-driven, high-level languages like Fortran and COBOL. COBOL was arguably the first business domain-specific language, or DSL. And it's still around today, I hear. They're wheeling old programmers out of old people's homes to fix banking systems. Great stuff. And we got Smalltalk and C, and every high-level language gained more expressive power and a high level of abstraction. And as programmers up the ladder of abstraction, we've climbed, and we have not finished yet. And as programmers, writing code the way we've always done, we've always relied on deterministic approaches. And as programmers, we craft systems with code and tests, and we produce software that hopefully, if all goes well, produces the same results every single time. And programming and software engineering is an absolute skill. Part art, part science, and so is managing the complexity of the systems that we build, and they're ever bigger, and that we build with code. And this is the deterministic path, the world of determinism, one we can reliably predict. Do you remember your high school maths? And when I like to teach functional programming to people that have no idea what that is, I ask them to forget everything they know about imperative programming or OO and just go back to high school maths. F of x, a pure function with the same input, always producing the same output. It's pretty simple, and often we forget just how simple that is. Teenagers can understand this. And so we produce the same output for the same input every single time. This is my journey through the world of determinism, and maybe this will resonate with many of you. I really like adventures. If you didn't know, I'm Australian. I often am traveling around the world. I like adventures and exploring. And 22 years ago, I traveled through Africa for a year. In that particular four-wheel drive, a Land Rover Defender with a buddy of mine, and we drove from London to Cape Town. And my Elixir journey took me through a decade of Java and J2EE, singletons, abstract factory beans. Those that were there will remember the EJBs, and then going back full circle to Pojos. And if those of you who don't know what a Pojo is, Java programming got so complicated and enterprisey that we had to name a term for just plain old Java objects. It was a bit of a mistake. And in my journey, that was followed by a Ruby and Rails productivity revelation for the next decade of my career. And I was suddenly, orders of magnitude more productive. And this absolutely felt like magic. And I wasn't alone. It seemed easy, but simplicity was just out of reach. And if you haven't seen Rich Hickey's classic Simple Made Easy talk, I would urge you to seek that out and watch it. It is one of the most timeless tech talks I've seen. It distinguishes what easy and simple really means. And one day I looked at some Ruby code at my job and I realized I couldn't reason about where the code was coming from. And I lost hope. But after some searching in the desert, I discovered the solid and timeless foundations of Elixir, Erlang and the Beam. The Erlang VM enabled enviable capabilities. It was surprisingly early, with many solutions to problems that we're still trying to solve today as an industry. Erlang, born of the 80s, did it before it was cool, the ultimate hipster tech, and it arguably did it better. It had distributed computing primitives before most of us had even heard of the internet, let alone had access to it. We had clean and clear abstractions for mastering distributed computing. Incredible stuff. And we had concurrent processing, even before multi-core processors were really a thing. Did you know that dual-core processors only started appearing on commodity PCs in the mid to late 2000s, which is surprisingly late? And Erlang gave us resilience, isolation, repeatability, well before Docker and Kubernetes came along. We already had health checks, auto restarts, process supervision, zero downtime upgrades, and built-in observability. All great things that other folks have been building for a long time, possibly in a more complicated way. And we had nanoservices before microservices was even a thing. And microservices solves a problem that Erlang and Elixir never really had, because we don't need many developers to deliver powerful systems with great tools. And the modular monolith was always able to be distributed as needed, and so we didn't really need some of the serverless solutions we see today either. Enter OTP. And as you may have noticed, the future is looking particularly agentic these days. That's LLMs or committees of LLMs going around in a loop, generating tokens and thinking and reasoning. And GenServer is the perfect agentic loop abstraction. It's a page of code, it's really simple, and you can build on top of that very easily. And yeah, the GenServer is a primitive that other ecosystems do not take for granted. But this just works. And Elixir sits proudly atop all of these battle-tested technologies. And what we get in Elixir and Erlang is functional programming, the simple kind without diving too far into category theory. We get immutability and pattern matching, which are language features which eliminate entirely large classes of errors in a practical way. And we've got types as well for our other checks. And Elixir is a simple, low-ceremony language optimized for shipping. There's one way to do things. There's no decision fatigue, which I experienced when I was working in JavaScript. And guess what? simple programs, they're easy to read, they're easy to reason about for humans. And if they're easy to read and reason about for humans, then they are also for our robotic friends. But we still don't have the level of reuse of software that we've always dreamt about, and we keep reinventing the wheel. Let me illustrate this with an example. This iceberg is your application, and modern applications are adding ever more requirements. What we were building decades ago seems trivial in comparison to the size of systems today and the requirements that they have just for getting something delivered. And frameworks and libraries only get you so far. So above the waterline is what you want to build. That's, the true goal, the value. But in order to get there, you have to build all of the things below the waterline. And there's a lot of things down under that water. We keep reinventing the wheel, duplicating solutions, resolving problems that I would argue that should already be solved. When I talk to customers, they don't even think about asking for things like login or security. That comes along for the ride. You guys have solved this problem before, and I have to caution them that it's not that simple. But it should be, right? Above the waterline, this is our goal. This is what we want to deliver as the value. This is where all the innovation lives, where our differentiation as a product or a software product is. It's where business people and lawyers and investors think the core IP of your business is. It's where all the high value lives. And down below here is, commodity, solve problems. This stuff's table stakes and really has, in our customers' minds, low perceived value. And really any time spent below the waterline is waste, in my opinion. We need to be trying to spend as much of our time as possible above the waterline. And now, with the advent of AI coding tools, we can build entire apps with increasingly complicated prompts and context, and we can smash that generate button, and we've entered the AI age where probability rules. The world of non-determinism. And now prompting and context management is the new skill. There are dice rolls involved in this, and we need to be aware that the output is sometimes good, but it isn't always. And because of the way LLMs work, it can never actually be 100% correct. There's always some randomness required. We need to take extra care that our programs still function precisely as we intended them to. And f of x gets replaced with a much more broad, infinite range of possibilities. And the range of inputs increases massively, and the output is never quite the same. It's a probability distribution. And this changes everything. The skill is in assembling the inputs to narrow down the possible outputs. And now, as programmers, we're basically managing probability ranges, and we're trying to minimize the range of that. And these memes are hitting a little close to home. C vibe coding, I hope you all know what that is. It's the, don't look at the code, just use an agent to build you a system and see what happens. And lots of non-technical folks are getting pretty far with this idea. But it's a little bit like a slot machine. We buy tokens, we pull the lever, and maybe there's a jackpot. 1 time out of 10, 1 time out of 100, and the rest of the time, there's nothing. Maybe you get an amazing app, or maybe you get a pile of hot garbage. It's hard to tell. And yeah, you could spend a lot of time doing this. And I will caution you to say that yes, AI-assisted coding may generate code faster, but often what happens is you spend time elsewhere. And so there's definitely a paper that supports that. And so we've been working with a thing called Ash framework, and that can help us focus on the top of the iceberg, the important problems in our application, without reinventing the wheel and leveraging everything that's great about the Elixir and the Beam ecosystems. So here's another view of that iceberg. Let's look at the layers of our application. In Ash, you start with the domain or the business logic layer, the one in red in the middle. And in this diagram, blue represents the user interface layer, and the green is the data layer. The core of your system and your application is written in what is effectively a domain modeling language. It's an internal Elixir DSL where we declaratively describe our system requirements in a structured way. And we aim to spend as much of our development time there as possible. We're doing work in the middle layer with the view to generating as much as possible of everything else, deriving the rest in Ash terms, using Ash generators. And so we build on Elixir's foundation of flexible abstractions to build bigger building blocks, and we build on that as a solid foundation. And so, can we have the best of both worlds? This is the deterministic path, the one we can reliably predict, and this is the axis where we're managing probabilities. We have LLMs furiously generating tokens at our request. And ultimately, we want both things, right? We want to have the productivity increases without the downsides. We don't want to be reviewing, garbage code and getting frustrated, because that does happen. And if we don't lean into AI, though, we end up being outcompeted by those who do, by those who master both worlds. And if we're just vibe coding and not looking at the results, then you're really just rolling the dice or pulling the jackpot lever. And so can we have our cake and eat it as well? Let's think about the desirable properties of our systems. Really what I'm saying here is that we want a deterministic core, reliable, solid, and we can do non-deterministic things on the edges of our systems. Or we can build determinism using non-deterministic tools. And I think it's also worth thinking about that some parts of our applications have different lifespans. I think you've all probably, if you've been around long enough, seen this. Some things change faster than others. Possibly the axis of disposable versus durable. The durable stuff sticks around very long, needs to be super reliable. The disposable stuff, less so. And I think, as non-technical folk build vibe-coded prototypes, we get more disposable stuff. Charity Majors did write a great article about this, and it's worth a read. We're going to have both kinds of things, and it's worth thinking about the time span and the lifespan of your different parts of your system. And so UIs are usually just windows into your core system, and I think in our world, the more transient parts or the edges of our system that can be disposable or vibe-coded potentially is the UI layer. But we really want to make sure that the rest of our system is rock solid and totally deterministic and durable. But we can use LLMs to build this stuff because it is, in Ash world, just a domain-specific language. It's just a modeling tool. And it's very declarative. So it works better than writing code. So, yeah. One thing that we've seen is the rise of conversational and intent-driven experiences. And these, I think, will ultimately replace static UIs that we see today. We've seen it with ChatGPT and Claude. And the reason is that no one really ever asked for apps. This was all we could do with the technology we had at the time. We couldn't do conversational interfaces. And really what people want from systems is users want answers to their questions. They don't want to poke around a static UI to capture data about the world or have an effect on the world and do things to the world through their system. They also want to react to the world. Why do you go look at an app? Because you probably think something's going wrong or you need to deal with something. But what if the app told you what you needed to do and when? The UI kind of tends to disappear at that point. And I think occasionally we just want to browse for inspiration because we don't know what a system does or what we want to do with it. And so I think this is definitely a distant fourth on the list of And that's the role of the static UI. And I think we'll find its role diminishes over time. We're getting new APIs and dynamic UIs, and they're already here. MCP, or the Model Context Protocol, is an AI-based, it's basically an API for LLMs, and it's barely a year old. It's matured quickly. I would argue it's not fully mature yet, but it's getting there rather rapidly. And quickly following that was the Agent Communication Protocol, the ACP, which came, I think it was in May this year. The agent-to-agent protocol came along as well, and they've actually now joined forces, thank God, so you don't have to support both of those things for talking to LLMs or agents. But is your application architecture actually ready for all of this? And how do you manage all of this new complexity? For example, someone pointed this out to me 2 days ago. OpenAI has released, and I don't know when they released it, please tell me later when that happened, because I missed the memo. But yeah, they've released ChatGPT Apps SDK, which allows you to basically build custom apps to be exposed into ChatGPT. And you do that by effectively exposing tool calls via an MCP server and then returning resources that represent your UI. And potentially it's sort of a dynamic custom UI. So that's pretty exciting. That's kind of like the new app store. So we'll see a lot of demand for that kind of thing. You know, ordering a pizza through ChatGPT, why not? It's kind of the new terminal for most folks. Another exciting thing in the dynamic UI world is C1 by Thesis. Now, this is basically a dynamic component system and an API middleware that lets you augment LLMs with dynamic interactive UI in real time instead of just text. And so that has libraries of, dynamic composable components that let you visualize the conversation and give you more dynamic interactive sessions with your chatbots. So we're basically getting software that's assembled and UIs that is assembled just in time for every interaction. Every question, every action, these UIs can potentially be unique. And it's easy to see how this may become some of the predominant lens on our systems, but it's also worth remembering how much complexity this adds and how many more requirements this adds to our architectures and our systems. How many APIs and visual representations can your app handle? Well, if you can't, get ready. There's going to be more coming pretty soon. So back to our pyramid. When we add AI on top of a more sound foundation, pretty interesting possibilities emerge. If you're building your app with LLMs, you're basically rolling the dice, effectively getting a completely different path every time. Comparing that with how Ash lets you deterministically generate the repetitive boilerplate that's under the waterline. Here we're declaring our domain. On the right side with LLMs, we're defining our prompt and building our context. And on the Ash side, we're deriving deterministically the result, whereas in LLMs, it's really not sure what exactly is going to happen. And so on the left, we're using tools to build our solid foundations. We can use LLMs and non-deterministic tools to build out this ecosystem, and that's happening as we speak. And we can even integrate non-deterministic agentic features into our apps. But remember to add the non-determinism to the edges of our system. Another exciting development is a thing called spec-driven development. Now, it's not exactly a new thing, but there's a sort of new sort of approach that's being trialed with AI tools where specs and not code are the primary artifact. Specs describe our intent in structured, testable language, and then agents go and generate code to match them. Now, hopefully, we're speccing well enough that we narrow the probability range, that it generates roughly the right result every time, but not guaranteed. An interesting model of what this looks like, and I think this may be one of the first ones, is the OpenAI model spec. So this is on GitHub and on the web. URL's down in the corner there. It's worth having a look because this is actually the spec, all written in Markdown, sitting in a GitHub repo in folders, basically describing how OpenAI should work. Now, it's probably not all of it, but it's definitely a big part of it. And really, it's descriptions of how the OpenAI models should behave, and it's got examples of good output, well, examples of the input and good output and bad output. And there's a whole ton of these, and it's definitely worth having a look. Martin Fowler published an article by Birgitta Böckler, hope I'm pronouncing that correctly. This is about sort of a first examination of the different kinds of spec-driven development. And what Birgitta has sort of laid out is that there's 3 different types or categories of spec-driven development. It's like starting with a spec, and I think that's sort of the first step in using like Claude Code to, hey, build me a plan before I start building out a feature, so at least I know where I'm at. And there are spec-anchored approaches, and then there's a more dramatic approach where you're actually using the spec as the new source code, and that's the thing that you do not throw away, and you keep around, and you may not look at the compiled artifact, which may be the code. So, worth a read. And she goes through 3 different things, 2 of which I've tried the first 2 very briefly. And SpecKit is effectively kind of like a proto Claude Code. It allows you to effectively build and refine a specification and gives you a plan, and it configures your custom commands for Claude Code or whatever coding environment that you're working with. And so these are more structured ways of building and refining formal specifications. I tried Kiro as well, similar idea. It promises to be a powerful technique. Definitely you need to try these kinds of things out if you're interested. But I found that you really needed to customize your approach to how you wanted to work. There was a lot of templates that were pretty generic. And so what other people have found and what I found is that you end up with a lot of tokens to review. There's a lot of verbiage. And I think if you can spend the time to get those specs really right, it's definitely going to be worth it. But you need to avoid ending up in what's called plan jungle. All right, so I promised an AI survival manual, and this is it. Remember Jevons' paradox? That implies that software is going to be a lot cheaper and much more plentiful. Now, that should be good for programmers and software engineers. And remember that programmers, we're so used to climbing the ladder of abstraction to higher and higher levels of abstraction. The AI age introduces a much bigger leap, but look, we've seen this before. And I think, based on what I said, like programming may end up looking like more structured specifications rather than the code we write today, but who knows? There's always a place for the code that we write today because it can't change too much. We can't actually let LLMs write in their own language because they could, create some format that would be very efficient for them to write in, not use very many tokens. They could reason about it, but we couldn't. Now, that might sound efficient, but it's not very good because what happens if the LLM isn't online? We need to be able to reason about it so that we know it's correct and we know what we want. And if we trust LLMs to interpret what the lower level output is, it could hallucinate, or worse, it could even lie to you about some lower level machine language representation. So taste, judgment, and experience really matter when anyone can build software. And we're already seeing super experienced software engineers become unreasonably efficient as they gain LLM augmented development experience. And when you can generate anything, knowing what to ask for, knowing when it's great, and how to generally minimize that probability wave is the biggest differentiator you can have. So it is a skill. And when things move really fast, we need to go back to the things that always mattered, they will help us. Tests, specs, documentation, super fast and tight feedback loops, automated checks, and guardrails, and making sure that we're doing CI and CD and deploying and merging our code often and deploying it often. And I think great specifications, which currently are code, but they're sort of scattered in our project management systems and so forth, they're going to matter more than ever, and we're going to want to unify those specifications so we can prove that our systems are actually what we said they should be. And the more structured the spec and the more deterministic the generation, the better result you're going to get. But security is absolutely paramount. It's easy to get distracted with all the new shiny tools that we forget the basic security principles. And the problem here is that LLMs can follow any instructions in content. Now, there are guardrails preventing some of this, but really, it's pretty easy to make an LLM do what you want. And that is kind of great for a malicious actor. And let's be honest, AI browsers are a relatively new thing. They're kind of useful, but really terrifying if you're logged in with broad access. And so things like secure sandbox containers are quickly becoming the best way to stay safe and keep things contained so access isn't a problem. If you don't read Simon Willison's blog, it's absolutely worth a read. He's absolutely on the forefront of what's happening in AI. And he termed the lethal trifecta. And because LLMs can interpret input, if they have access to untrusted input or untrusted content, it's easy for malicious instructions to be included in a prompt. And if they have access to private data and they can externally communicate, they can exfiltrate private data pretty easily. And so that is the lethal trifecta. Do keep that in mind. I don't think there are any live exploits of this yet that we know about, but it's pretty easy to see how that could happen. And I think if you're still skeptical about AI, I would urge you to lean in, but even if you're an AI fanatic, stay skeptical. It takes time to build up the muscle. The models are getting better and better, and it's incredible how far we've come in even a year and a half. But yeah, lean in, see how far you can take it. And don't be deluded. Don't fall prey to cognitive biases like the gambler's fallacy. Think of yourself at the slot machine pulling the handle without really thinking about how long you've been there and whether you're holding on to that mystical jackpot that will never come. And so I think you need to hone your critical thinking skills because it's easy to forget. And it's easy for humans to be deluded as well. If you've ever seen Wikipedia's list of cognitive biases, it's a pretty good read. It's pretty long. And so, yeah, humans aren't perfect either. And so understand with AI that you're really managing a probability distribution and you're trying to, like a good poker player, minimize probability and variance. And as we saw, the conversational and generative UI, as well as intent-based experiences, will absolutely, in my view, take over static UIs. I think we'll be stuck with the static UI for quite some time, but yeah, I think we'll see the emergence of, and we already have, chat interfaces alongside our sort of traditional static UIs. And I think the static stuff may disappear as we can do more with the conversational interface. And as we saw, like we're seeing lots more, LLM-focused APIs to go along with our GraphQL and our REST and our gRPC and so forth. And so you need to prepare your app for more of those, particularly agentic ones. And as we saw, if you want to build a GPT app, you need an MCP server. They're relatively easy to put together, but tools like Ash can help you, have your GraphQL, your REST, and your MCP, and whatever else comes along as well, without doing any extra work. And fundamentally, speed of change here is the new competitive advantage. If you're architecting your systems to make and this was always the case, this was the whole point of Agile, is if you can change your systems easily and have them ready to change, that's a massive competitive advantage. And if you think you're late, you're not. There's still time. I think this is, a long story arc, and we're still relatively early. And let me urge you to explore with LLMs, remember to build with deterministic and reliable tools, but use non-deterministic tools to build those deterministic ones. And let's build on solid foundations. Thank you.